Hi, Mitch Wenger back with another video on data analytics and machine learning. In this video, we'll discuss other techniques that can be used with text. Hope you enjoy. Okay, let's get started. As you might recall, our basic bag of words approach turns every word, minus the stop words, into a term or token. Of course, sometimes the order of the words matters. We can begin to address that by evaluating sequences of words, which we call engrams. The most common approach is to analyze word pairs, called bigrams. When we increase the number of adjacent words, we can say we're evaluating engrams up to 3, up to 4, or more. Each engram then becomes a feature in our analysis, which proceeds as usual from that point. As you might imagine, accumulating engrams adds to processing time, and the resulting dataset is generally much larger. It's also a bit sparser, as many engrams often occur just once in the entire corpus. Feature selection is an important step, then, in your analysis when you consider engrams. A variation on engrams is to analyze for word pairs or trios, etc., that appear in close proximity with each other in the document, but not necessarily adjacent to each other. Depending on your closeness measure, this can also increase processing time significantly, and also the size of your resulting data set. Another approach to text analysis is named entity extraction. Although this appears similar to tokenization and/or stemming, it's a bit more complex in that it's based on a knowledge approach to the corpus. Here are some examples. The company IBM, for example, and I've actually run into this particular example in the past when I was doing consulting engagements for clients that were merging vendor lists for acquisitions, or even when they had multiple offices handling purchases. So, of course, you've got IBM, but some accounts payable clerks may have typed in I period, B period, M period in reference to IBM's old name. Just as a side note, IBM doesn't technically stand for anything anymore, although originally it did stand for International Business Machines, the name of the company, for a long time. We actually ran into some instances where the clerk had typed out International Business Machines. Likewise, you might find for Microsoft, back way in its early days, it was actually called Micro-Soft. And of course, other things like the New York Mets. You can take the whole name of the team, just the Mets, NYN as an abbreviation you might find in scores for the New York team in the National League. The Amazons, a lot of sports reporters may call them that. Topic modeling is an approach that adds a great deal of complexity to the text mining process, primarily because it attempts to deal with all the complexities and nuances of language. In a nutshell, it works like this. From a document, words get mapped to a number of topics that are identified in the document. We can use unsupervised data mining techniques here, such as factorization using latent semantic indexing, probabilistic methods, such as latent Dirichlet allocation, and many other techniques. Individual topics are identified via statistical patterns found in the data. From there, a final classifier that you can see up at the top is defined using these intermediate topics. In this example from the journal Science, we can see that keywords have been grouped into 4 individual topics. Topic 1 has words such as gene, genomes, genetic, DNA. Topic 2, organism, survive, life, evolve. Topic 3, brain, neuron, nerve. By the way, the article extends beyond what you see here. Topic 4, computer, prediction, number, data. Topics may or may not be identifiable, but they often are. For example, in this case, we could probably give each one of these topics a name. And that's true in topic modeling as well. We can give descriptive names to the topics, much like we can in clustering or PCA, or we can just leave them with their generic names, T1, T2, T3, etc. The choice in naming topics doesn't affect your analysis, but it will have an impact on the intelligibility of your model. So what are some applications for text mining? Well, if we look at news feeds and compare them to stock price movement, these are called event studies. And this is something that researchers have done for a long time now. As we evaluate the event study, it's important to consider, well, what time frame should we look at? How many days after the story comes out should we consider? Or maybe these days, even how many hours? On the other hand, should we look at time frames prior to the release of the story? That might be a way to suss out some insider trading, for example. And of course, many factors affect stock price, so generally it's wise to keep the time frames small. For the most part, it's best to look at movement only in the same day. Now, what level of accuracy can we achieve? Should we try to predict the exact price? Or it might be better just to simply predict the direction of movement. And of course, there may be a lot of other noise in the data that affects the stock price that we need to consider. Stock prices, of course, move for many reasons. In general, we should set a threshold of movement, that is, predict a relatively large up or down movement for an event study. That way we can have a little bit more assurance that the movement is related in some way to the event. Which news stories should we consider? Stories about the company's industry in general? Stories about the general economy? As you might imagine, it's best to stick with the specific company being evaluated. But even then, specific company stories leave weaknesses. What about stories that just include that company in a long list of companies, or that mentions multiple companies? Anyway, event studies are a long-standing use of text analytics, starting well before text mining software was common. And yes, the data back then was collected and coded by hand. Now, what are some other text mining applications? Well, product reviews can be used to help evaluate warranty reserves, for example, or map out future sales trends. Twitter and social media can be used for sentiment analysis in many areas. Email messages can be evaluated for sales channel analysis, maybe for employee retention as employees chatter back and forth with each other, corporate espionage, and of course, our old favorite, spam filtering. That's it for this discussion on additional approaches to handling text. I hope you found it useful. As always, be sure to check out the other videos in this series.